Hello, guys. I hope everyone's safe. Today we're going to talk about assignment 7. This is going to be the assignment where we do the structure of our pavilion. We're going to do uh, the inner raftings as well as the bracing of our pavilion. But before we jump into this tutorial, I just want to talk uh, about the previous assignment. I did receive all of you guys' assignment. Most of you submitted only the one page in here. As described before on the other tutorial, I did wanted the 2 pages with the single surface shown. I don't care about you guys putting this. This is more for you. The layers are going to be for your information when you're modeling this pavilion. So I didn't really want to see this in your assignment. If you put it there, that's fine. I'll count it as extra, but I only wanted to see this. Another thing that I want to touch base on is when you're submitting these assignments, please make sure that you submit both the PDF and the Rhino file. That's just better for you because if I have a question, I can just always open your file and then just poke in there just to see if there's something missing or if something didn't print. So it's better for you if you submit both. If you only submit the PDF up to this point, it's fine. But from now on, please submit both of them. If you've only been submitting the Rhino file, just take into account that it takes more time for me to review those because I have to open the file on my laptop where I have Rhino. So it'll take me a little bit longer to get your assignments back. Nevertheless, just please submit the PDF and the Rhino file. Okay, so let's jump into Rhino and start going through assignment 7. Okay, so once you open your file, this is what we worked on the previous class. You should end up with something like this. If you follow my mouse, I am hovering over the single surface that we did on the previous assignment and then just the groundwork that we have going on at the C plane. One of the things that I do want to change, I know I mentioned this before on the previous assignment, when we are doing our sweep with the 2 rails and the 3 profiles that we created, I know I mentioned that we should rebuild the surface. And I gave you the number of iterations that you should rebuild it with. I believe I said 10. But because we're rebuilding the surface, some of the curves are failing. As you can see here at the end, if you follow my mouse in here, this sweep is actually not conforming to our profiles because it's being rebuilt when we're doing this surface. So we're just going to recreate it again, and this was a mistake on my part. So let's just do it right before we jump into the tutorial. We're just gonna get clean geometry if we do it the right way. So we're just gonna say again, sweep 2. We're gonna pick our 2 rails. I know we talked about this on the previous one, but I just wanna redo it with you guys. And hit enter. And then this is the part where we said that we were gonna rebuild it. So let's just leave it at do not change the cross intersections, and let me just zoom in here so that you guys can see that now is conforming to that curve. Before it was being rebuilt, so it was just deviating from that curve. So we're just going to go into and check this do not change the cross sections. We don't need to maintain the height or refit the rails. You can see that just changes how our surface is. We're not going to do that. So everything is at default, and the only one we're picking is this one. So we're just going to say OK. And this is our starting point for assignment 7. So what we're going to do before we start going into this, I just want to show you, if I jump on my other file, and let me just turn off a few layers in here. What we're trying to do is this substructure that we have going on in here. And there's a certain way that we need to do it in order to get the curvature of the single surface. And we need all the rafters to follow that curvature of our single surface. So this is what we're going for. I just like to show you before we dive deep into it. Okay, so we're back in our starting file and we have our single surface. So the first thing that we need to do is to give our single surface a thickness. So what we're going to do today, we're going to use the command offset surface. Okay, and we're going to pick our single surface, hit enter, and you're going to notice a bunch of arrows in here. So what these arrows are, they're just showing you the direction of the offset. The distance right now, if you look at the sub menu, we have a distance of 12. The corner is round. That means that whenever, if we were to have a sharp curve in here, a 90-degree curve in here, or a 90-degree angle in here, when it's going to do the offset, that's going to become round. So we don't need to worry too much about this one. The solid, we like to create a solid after the offset. If we say no, it's only going to offset the single surface and it's not going to cap it. The lose option here, we have it set to yes. What this means is that it's going to offset the same surface and it's going to keep its properties. If we say no, it's going to generate its own properties. So I'm going to just say no so that you guys can see what happens. And as soon as I click no, the tolerance is at 0.111. The next one is both sides set to no, which is what we do want. And the delete input set to yes. It's going to delete this single surface after the offset. And then flip all. This is just going to flip your direction of these white arrows. So we're just going to click flip all. So now it's doing that. And I'm just going to hit enter. And it's running through the process and it's just offsetting the surface. Now you can see we have a thickened surface in here. So this is what I was talking about. See the number of multiple squares that we have here are not the same as the ones that are up here. So what it's doing, it's trying to keep the same curvature, but at the same time, it's rebuilding the lower surface. So that's going to cause a little bit of trouble for us because if we go to the other side, you can see that it starts meshing with itself. It starts crashing with itself, and that's something that we don't want to do. So I'm going to hit undo for one. Okay, and now we're going to run the command again. So offset surface. Select my surface. The distance is fine. The corner, we don't care about too much. Solid set to yes. The lose, we're going to set it to yes because we do want to keep the same curvature here. And then we're just going to flip all so that it goes to the inside. And then we're going to hit enter. Now you can see that the geometry is very clean. This is what we're going after. See how there's no subdivisions of that surface in there. And then if we go to the other side, you can see that it's a clean, not intersectable surface in here. So that's what we want for our surface. Now that we generated our thickened surface, what we need to do is dissect this surface in a way that it's creating curves that are going to become our rafters. So let me explain you what we're going to do. We're going to select this surface in here, and then we're just going to type section. And what that's going to do, it's going to create a section between the two given points. And those two given points are going to be driven by you. Notice that Rhino is asking for a point for a start section. So we're going to click this point, and then end of section is going to be this one here. Notice how it's actually doing a profile at that intersection between the thickened surface and the grid line that we have running below here from our previous assignment, the groundwork. So basically what you have to do is go through the entire project and then just pick a starting point and an end point. And you're going to be using your ground lines to generate those sections. Okay, so let me pause it here, and I'll do it on my own. And then I'll come back once this is done. So I'll see you guys in a bit.
A few moments later.
All right, so we're back. A few things that happened to me while I was doing this. I was working on the wrong layer. So make sure that when you're doing this, that you're working on the right layer. I was working in just the single surface layer. Make sure that for this assignment, you work on the 0 to rafter layers and its sub layers. You're going to notice that my layers look a little bit different, and that's just because I just switched the name around so that it's easier to understand. What this is it has 0 to 0.1 guide rafters. That just, rafter guides, it's just backwards. And then the thickened rafters is nothing else than the rafter structure, which are the 3D objects. You can pick either one. You can either stick with this one or go with the new one that I just renamed just now. It doesn't make a difference as long as you have the objects separated on the layers that they're supposed to be. Okay, so I'm going to minimize that. So we created the rafter profiles that we're going to thicken. Let me turn off my single surface layer, and you're going to see that now we have all the rafters curves that we're going to thicken. Notice that how there's an issue on the beginning profile here, and there's an issue at the final profile here. And the issue is this surface right here at the end is not completely perpendicular to this line. It has its own tangency here. You can see it's a little bit wonky on the top right here. You can see how it's like protruding out, and that's okay. We're just using that surface for reference. Now the way to fix this is by turning off our single surface and then just isolating this curve that we have here. And rather than doing an offset for the surface, we're just going to do our typical offset and keep the distance the same, 12. I think we talked about all of these before when we did the offset in class. The one thing that I do want to point out, make sure that you have the cap for flat. I'm going to set it to none so you see the difference. If I do none, notice how it's just doing an extra line here, and then you're going to have to connect it on the bottom here. Now, if I do the cap to flat, notice how it's doing the line for you. It's just an extra step that you don't have to worry about. So we're just going to go with flat. Um, and we're just going to do the same for the other side. So we're going to do offset. Then we're going to pick that and offset that. Now, even though I'm on the same, I'm on the right layer, it inherit the properties of the previous curve. Notice how this one is in our groundwork curve line. So what we need to do after we offset, which is make sure that you right click the layer that you want it on and change the object layer just to keep things more organized. And then we're just going to select this guy, right click, and then change object layers. So we should have something like this. Now the next step to do the assignment is to make these as 3D objects. So we need to thicken the rafter itself. It's nothing really complicated, and we're going to use the same command that we've used on the first part of the semester, which is the offset extrude curve. We're going to pick the curve, and then we're just going to give it a thickness. Because we created this from the surface itself, it remembers the direction of it, so you don't have to worry about the direction. And then I believe this is 2 inches for the extrusion amount, and you can see it on your handout, which is going to be right there if you follow my mouse. It says 2 inches. Okay, so we got the first one, and now we can just say extrude curve and do the next one, which is 2 inches. And again, I'm going to pause this and I'm going to do it on my own so that you don't have to listen to me while I do it, since it's just the same process over and over again. So we'll be back in a second. Okay, and we're back. We just finished doing all the rafters. You can see that they're all thickened with a 2-inch thickness for all the structure. I took the time to put it in the right layer. You guys should do the same when doing this assignment. Before we continue, I want to bring the handout and explain a little bit more of what assignment 7 is in terms of deliverable. We are going to create, again, another 2 sheets. We're going to create one with a 3D view, and this is an isometric view. This is not a perspective view. Make sure that you have a isometric view set up in here. You don't need to have the shadows in here because we have not talked about the shadows nor the material, but you can have the 3D of it on a hidden line style or pen style view. This is just a back elevation, meaning that you're seeing it from, if you follow my mouse, from this point facing that way. And this is a front elevation, which means that if you're following my mouse, that you're somewhere here and then you're just looking at it straight to the front. So these elevations and 3D are required for assignment 7. as well as the second sheet, which is a plan view of this. Uh, the structure needs to be there, the dimensions, and then the text that we have here, as well as the annotations for the work point, um, as well as the bracing profile. Now, the bracing profile we haven't really talked about because that's what we're going to do right now. But I just want to bring some attention to where it is and what it is. Uh, and what this bracing profile is, that is just the profile of uh, the connection between one rafter to another one. So that profile is going to be extruded if you follow my mouse from this point here all the way here. So what you're seeing down here is just a collection of the bracing elements that we have here. Now, this assignment, I believe the video is going to be a little bit shorter than the previous one, but the amount of work that you're going to be doing is going to be more than the previous assignment. And that's just because you have to manually do each one of these individual bracing objects in here. You have to do it one by one from rafter to rafter. Each connection between the two rafters has 9 um, bracing elements. And let me just bring up the other assignment, the previous, I'm sorry, the completed one, which is our reference. So pretty much what I was saying is you have all these members in here, all these objects that are the ones that you're going to do. So your task is to do each one of those throughout the entire structure between all the rafters. So that's the assignment, and as well as completing and setting up the sheets. So now that we talked about that, so how do we go about creating those? So we talked about the rafters, how to create those, but we haven't talked about how to do the bracing between one another one. And the way we do that is by one, creating a profile, which is the profile that we were just talking about, which is the 6x2, yes, a 6-inch by 2-inch. So we create a profile, and then from that profile, we orient it perpendicular to the curvature of our rafters. So we have to orient it here. And then once that's done, we need to extrude it from one rafter to another one. So the way we're going to do that is by using a few new commands. So the first thing that we need to do is create the profile. You guys can see it here. I already created, so I'm going to delete it just so that we can do it together. So let's start a line, and we can either type polyline or we can just click the button, and that line is going to be the 2-inch by 6-inch by 2-inch, and then C for close, just to have that profile. So that profile has to be oriented in here. And to do that, if we go back to the reference, I'm going to zoom in here. You guys can see that it's a little bit pixelated, but you can see that there's a space in between the border of the rafter and the bracing object in here. And that that distance is the same thickness as everything else, which is 2 inches. So let's do that. So we're just going to create a curve that is going to be our guide to orient all of these guys in there. And to do that, we're going to use offset, not surface, just offset, which works with lines. And then we're going to pick the edge. You guys can see there in this selection menu. If I pick the curve, I'm going to offset the entire curve, which is what we don't want to do. I'm going to click it just to show you why we don't want to do that. We say 2 inches. Notice how it's offsetting the entire thing, including the inner border in there. So we don't want to do that. So when you run the offset command, what you want to pick is extrusion edge. And then we're going to say 2 inches down. And then we're going to click. And we have something like that. Now, because we had the cap option enabled, it created not only this line, but it also created another line on the top. We don't want that. So let me undo again and then run the offset. Make sure that our cap is set to none. Select our extrusion edge. Make sure that we have a distance of 2. And the direction is going to be on the interior. So we're going to just go right about there. And now notice how we only have a line now in there. So that's what we want. We just want a single line in here that is going to act as our guide when we're orienting this profile in there. So we have the guide there, we have the profile. So now let's move this guy in there. So let's do, the command is going to be Orient. Orient on curve. And it's going to prompt me for the objects to orient, which is going to be my profile. I hit enter. It's going to prompt me for the base point. We're going to pick the top, the middle of our profile in there. And then it's prompting me for the selection orientation curve, which is the guide that we just did. And you're going to see that, yes, we have the curvature that is showing a preview along that curve. We can specify the copy in here on the sub menu just to have multiple instances in there. But it's on the wrong direction. It should be on the other side. So I'm going to undo one time and run the command again. So orient, orient on curve, select my profile. And rather than selecting this midpoint that is on the top, we're going to select the midpoint that is on the bottom. And we're going to select the curve that is right there. And now notice that it's actually working. Now we need to have 9 objects in here at equal distances, which we haven't done. We only have the curve and the profile. We know it's going to work because we can copy it around, but we don't know exactly where. So let's figure that out. I'm going to undo one time. And I am going to say that I want to divide this curve in 10 equal segments. And the way we do that is by using a command that is called divide. And we select the curve that is our guide. We hit enter, and we could do it by length, or we could do it by segments. We could split them. We don't want to split them. We want to keep them as a single line. We could mark the ends, which is what we do want to do. And we could group our output, which we don't really necessarily have to group them. So yes, the number of segments are going to be 10. So I'm going to hit enter. And notice that now we got points where the intersections are. So if you count the points, 1, 2, 3, 4, 5, we have 11, and that's because we're counting the endpoints, right? So it'll be 10 inner points that we need. So those are going to be the intersection that we need when we're orienting this profile here. So we're just going to say orient on curve, select our profile, pick the lower midpoint of that profile, and make sure that you have the copy set to yes. Otherwise, you're going to have to repeat the command for every single one. And we're just going to say the intersection of that. Make sure that we have the intersection enabled. We do. Okay, so there's a point. I'm snapping to the point. And let's keep doing it to the point. Okay, so we have our base profiles oriented the right way, and we have them oriented along this guide. Now all we have to do is extrude them from one side to another side. Now, I didn't mention this, but we actually did it on the wrong side, and that's because there's no other rafter before this one. So technically, when we do this, we should be doing it on this face so that we can extrude to this face. Now you can see that we can't really extrude it because there's nothing in here. So I'm going to pause the video and then I'm going to recreate what we just did on the right face, which is going to be this one. So we'll take a pause and then we'll continue.
Eventually.
All right, and we're back. So we just finished redoing the curve guide that we did, and then the profile that we had on the right face this time. Notice that since the bracing is going to expand, is going to link this rafter to this rafter, we did it on the faces that are touching that specific brace, which is going to be the interior one here and then the interior one there. And that's just because we want to be able to see the curves here, and then we want the geometry to actually touch this face here. Now we have our guides here, and we also have our points, and we have our profiles here. So now extrude um, let's extrude this geometry right there, this profile in there onto this face right there. Now, if this was simple geometry, we could just do extrude curve, pick our profile, hit enter, and then just extrude it. But notice that if I do that, this is actually going to go perpendicular to the profile that we have here. And because we have a curvature here that we need to take into account, this command would fail. Now, one way to fix that is to draw a line here between the point that we have there to the point that we have there. So let me do it again. I hit escape. So one way is to draw a line there and say I would like to extrude the curve, which happens to be this curve. Upon hitting enter, it's still doing the same, and that's because we haven't modified our sub options here. The direction now, it's going to be this point to that point. Notice how it's actually extruding the right way. It's starting to extrude from this face. Notice it's not going inside. But as soon as it gets here, if I were to finish this, notice I'm actually going to finish there. So just so that you guys can see how it's meeting in there. Let me set this to ghosted. Notice that the direction is right, the profile is right, but the way that it's ending is wrong. And that's because it's ending perpendicular to this line in there. So one way to fix that is by doing the extrude curve, picking the extrude curve. The direction is going to be the beginning of that point to the ending of that point. We don't necessarily have to draw the line because we're going to get prompted what the 2 points are, which we can just pick the points that we already have on our guides. Now, as to how to fix that, there is an option here that says to boundary. So if we click the to boundary, we can actually pick a face. Notice how I'm picking the one that is the face that we currently have this profiles on. So we're going to pick that face, and it's going to keep the same direction. It's going to keep the same profile, and it's going to use this face as a boundary to chop off our extrusion. So in the assignment, what I'm looking for is for you guys to be able to modify the direction of the extrude curve, as well as modify the ending of our extrude element in here. You guys can see that the one on the top right here, if you follow my mouse, this would be a preferred option. The one on the bottom, it's really messy. You guys can see that we have geometry intersecting with another geometry. So this one would be counted against you if you do the assignment this way. So let me delete this, and then let's run through it again. So I'm going to do extrude curve. We're going to pick the curve that we want to extrude. The direction, we're going to select direction. Now, if you don't want to keep going to your sub menu and clicking the direction on and on and on, just make sure that the underlined letter, which is D, you can just type that, D for direction, and then you can just specify the 2 points. And then to boundary, notice how the T is the one that is underlined. So I'm just going to hit T, enter, and I'm going to pick this face right there. So that's 2. So I'm going to pause this, and I'm going to make the entire bracing between these two rafters, and then we'll come back and talk a little bit more about the assignment, and I also want to talk about how to print things the right way, how to make in black and white, and modify the line thickness of our drawing. So we'll be back in a second. Okay, guys, so we're back. I took the time to do all the braces in between the two rafters. You can see them here. So uh, your job is going to be to do the same process in between all the rafters, and the amount of rafters it's going to be the same amount that we have here. So it's going to be nine. Excuse me, the same amount of braces is going to be the same amount as we have here, which is nine braces in between the rafters, and that's going to replicate throughout the entire structure. You can see here that I have a reference point tag, and that I just did that so that I knew which middle point to use when I orient to my curve. You can have it if you like, but it's not required, so I'm just gonna delete it. Um, the last part that I wanted to talk to you guys about is when you're working in these assignments, the end point of this entire project is going to be that within one file we have the multiple assignments, and that's because we have all the assignments down here, and at any given point, when we start adding more information, we would like to either turn on or turn off information in our layouts. And we do it so that we have all the information available to us at any given point, but at the same time, we have to filter it. Uh, and that's because as we start adding these elements, they become visible in the previous assignments. So your job is to uh, try to keep your previous assignments clean of the new geometry that you add on the upcoming assignments. Um, for example, this is assignment one, and you could see that that excuse me, that we have the rafters shown here, even though this layout, assignment six, the groundwork, it's only showing the groundwork. So one way to manage this process of new information and old information is going to be to turn off the layers. And we talked about this on the first part of the semester. How do we deal with information that is in there, but we don't want to show it in our layouts? Before we use hide in detail command just to hide objects. Um, in this second part of the semester, what we're going to do, we're actually going to start turning layers on and off because we took the time to categorize all the layers into their own specific layers. Uh, so the way to do that, I'm going to turn everything on, and just to show you, in my perspective view, which is going to be our model view, we have all the layers on right now. And you can tell by looking at this light bulb here. So I'm going to expand this so that it makes more sense. Notice how there's only one light bulb icon in here when we're working in our model space. And that's just going to turn the layer on and off. But when we start going into our layouts, you're going to start noticing that we have another, if you follow my mouse, we have another light bulb in here. And what this light bulb deals with only the active layout that we have. In this instance, you can see that we see the rafters in here, but if we turn them off, they don't really turn off at all. And that's because we're outside of the viewports. Um, so these guys deal with the active ones. If I enable my viewport in here and start turning these layers off, you're going to notice that those objects turn off I'm going to get out of my viewport and go into my perspective. And you can see that everything is still on in here. That's the way that we want these assignments to be portrayed. We want in our model view, in our current model view in here, we want all these layers on, but when we go into our assignments, we want to control the layers of our active viewports with these visibility light bulbs that we have in here. And the same thing goes for what type of line type do you want to show and what type of color. If you follow my mouse here, um, you can see that the layout um, visibilities are shaded in the layer. If you follow the rafter structure layer or the rafter guide layer, all the options are in white, but the ones that deal with the viewport, the active viewport, are in gray. Now that is not really visible when you start clicking on them. You can see that when I click, the colors go away, but that's a good indicator of what visibility is, um, what visibility we are working with, either layout or the model visibility. Um, so the light bulb turns the layer, the active viewport layer on or and off. The color on the right, just just the right of the light bulb, that color is the display of the layer. That means whatever display color you give it. For example, if we change the groundwork layer display to another color, let's pick blue, that's going to change to blue. Now, the one on the right, the one that looks like a diamond, that's actually the print color. Now, the print color by default is the same as the starting color of your layer in here. Notice that it's green, and then the default color of our layer is green. So by default, it's going to be always the same color. We can start changing it here. I'm going to set it to black and hit OK. And notice how that didn't change at all. Now, the reason why that didn't change is because we have to enable a specific command in order to be able to visualize how things are going to print. And that command is going to be print display. So let me just type that one. Print display. Okay, notice that the current state is off. We can switch it either to on and off, and it's going to emulate how it's going to print here in our layout. The color is set to print. Once we turn it on, it's going to show the print status, and then the layout line types equals on. We'll talk about it later, but for now, let's just turn it on just to see what happens. Notice that when I click state, we have either on or off or toggle. Those are pretty much self-explanatory. I'm just going to turn it on. And notice what happens here. When I turn it on, it displays the color of the print color that I specified. Now, notice that in here is green. So don't get confused, because right now I'm outside of my viewport. So I'm going to double click and notice that now it's showing black for the print. Now, if we set this to, let's say, a cyan color and get out, then it's going to show that specific one, even though it's not shown here. So you have to activate the viewport in order to change the color. So I'm just going to leave it as black in there. Now, talking about the actual command, print display. So print display. As far as the color, it's equal to print. That's what we were just talking about, this diamond color that we have here. if I click on the color option, we have two, either print or display. They're just inverted. The print is the diamond color that we see here on the right. And then the display, it's actually the square color that we see in here. So that's the main difference. I'm just gonna leave it as print, and I'm gonna activate this so that you guys can see the next option. So print display, I ran the command, and then we have the other option that it says layout line types equals on. If I have this set to off, whatever unit I have in my current model, notice that we can only see that they're dashed if we zoom in really close. That's because our line type scale is really tiny. And we can see the dashed lines if we zoom really close. Now, that is going to be the same if I have that setting set to off. Notice that when I start zooming in, I can only see the dashed lines when I zoom in really close. So by default, I would recommend that when you use the print display option, set your layout line types to on. That way, each individual viewport it's controlled independently. So it's gonna, have a better control of your line types. So as a default, just leave it as on. Okay, so we cover the colors and what is the layer display and the print display. The print width, it's just the thickness of the line that you want to give it. The line type is going to be driven by the line type of your main layer. I notice mine is hidden here, so we can't override the line type in our layout print. One thing that we can do override is individual objects. If we select an individual object in our current viewport, and if we go into its properties, notice that the current curve that I have selected is the print width is set by layer. If we override this to, let's say, something really big, let's say 2, and then we get out of our viewport, then you can see that because we have the print display set to on, it's gonna show us the preview of how that's going to print. Now, it doesn't show black because that specific layer, our curve line layer, we don't have anything, any color for the print. So we're gonna set it to black. And as soon as I do that, then we can start seeing some different results here. Now, keep in mind that this is per viewport. As soon as I activate another viewport, these are going to reset to their default if you haven't modified them. If you have modified them, they're going to go back to whatever previous modification you had. So the goal of this is for us to start having drawings that look more like this, with different line weights, and you can see really clearly which one is the rail, which one is the profile. So for assignment 7, what I want you guys to do is rework assignment 6 for the print aspect of it. Make it look just like this one, the one for the one in the package that I provided. Also include that 3D isometric of the single surface, and then work on the next 2 sheets, which are the rafters and the intermediate bracing between each rafter, and that's going to go throughout the entire structure. Remember that's the assignment, to do every single intermediate bracing of the entire pavilion. Also, when you get to this sheet, make sure to introduce or to modify your lines. I would like to see everything in black and white, no color anymore. So if you send me, or if you submit anything with color, it's going to have some points deducted, so just please keep that in mind. We talked about how to do text, and we haven't really talked about how to achieve this hatch up here. So let's just talk briefly about how to go about that. And I'm just going to use this as an example. If you go into uh, drafting, if we go into the drafting tab in here, you can see that we have some tools that are called hatches in here. Or you can also type hatch, hit enter, and then it prompts you to select curves. I'm just gonna pick the circle as an example. Please don't do that. And after you select the curve, you specify what type of hatch you would like to have. I believe I always use the smallest one, which is hatch 1. You can always modify the scale and its rotation. Let's just set it to 45, just so that we can make it so that it looks, um, oops, excuse me, so that it looks just like that. So a very dense hatch at 45 degrees going up. So we're just gonna do that. So 45, and then we're just gonna bump that down to, let's say, 0.5 and hit OK. And notice that now we have this object here, which is the hatch. As I previously stated, don't do it in this precise location. Just follow the handout. I just wanted to give you an example of how to do that. One thing, you could do it inside the layout, uh, or you could do it outside. I chose to do it outside. Notice how I can't select it anymore, and that's because I need to get out and then I can't select it. So either if you do it inside or outside, it doesn't matter as long as it's in there and the color is being modified, and the color of it is being modified and the hatches are being modified. Um, so that's pretty much all that I have for you for this assignment. As I said before, this is going to be a short one, a short video, but the assignment itself is going to take you some time because you have to do a lot of braces in between the rafters. So please let me know if you have any questions. Remember, try to email me Monday through Thursday. I can get back to you as soon as I can. If you do it Friday, I am a little bit more busy Fridays nowadays, but I'll try to get back to you as soon as I can. So let me know if you have any questions, and good luck, guys.